Right, here I am.
Hi, Raj. I should be calling you Dr. Raj. Is that right?
I'll take whatever I can get. Sure.
All right, I'll call you mate from now on. Good. That's nice and British. But
All
you are
right.
also not in England. Is that correct?
I am in the United States.
So I had a quick. I've seen a bit of your work online. Not everyone will have done, but I'm sure a lot of people have done because you've done a TEDx talk to do with the beauty of mathematics as well, and
Yeah.
worked with is it James Tanton on the Global Math Project?
Yeah, part of the Global Math Project with James. James is one of a kind.
Well, I'm really glad that you're here. I know you're going to show us some interesting things. I had a sneak preview of the sort of thing you might show us, but I'd like, if possible, can you say a little bit more about your background in mathematics and maybe why that overlaps with magic at all?
Yeah, so my background is, I'm one of these people who love math his whole life, just like probably a lot of people here. Got my PhD in physics, and then, always wanted to be a teacher. So I quit my job 13 years ago, started a math program for kids here in Ohio. And just trying to get more people to fall in love with mathematics. One thing I like to say is I like to make math irresistible for kids and for adults.
And that's a bit of a tagline in the videos I've seen. That's your
Yeah,
job. So you
yeah,
find math is irresistible. I'm going to say maths. I'm sorry if that offends you, but hey, other people, I actually quite like the American because not sure I can defend the pluralization of the word math, but that's how I say it. So I find maths irresistible. You clearly do, but why is it? Do you think that some people don't? I think you have thoughts on this, don't you?
but I have a lot of thoughts on this. I could take the whole half hour on that, but I think the biggest thing is that when we take mathematics into schools, we just do so much to take all of the curiosity and surprise out of it. And that's one of the reasons I'm super excited to be here in the Math Magic Show, right?
Yeah.
We want to bring the surprise of mathematics to you in regular everyday math. You don't have to be a genius to figure any of this stuff out. You just have to be curious, and everybody's curious. So I'm always looking for things that are just really easy for people to make sense of. But when you first see them, you're like, wait, what? How is this possible? Because if you do that, then I know you're going to lean in and you're gonna actually participate in the mathematics.
And so you said you quit your job to become a teacher. What was your
Yeah.
job before teaching then?
In the good old days, I worked for Intel. Back in the day, where it was prestigious to work at Intel,
Surely it still is to a
probably
certain.
still is, but and I worked in R&D, so making microprocessors and all that kind of
But
stuff.
we now both agree clearly, and so does everyone else watching, that it's far more prestigious to be a teacher of mathematics.
100%.
Good. I mean, because I have a similar life story. I was a teacher in secondary school in England, and now I get to do sort of maths outreach a bit as well and talk about things like maths on Numberphile and YouTube videos. But I think both of us share the same passion is that we've seen the bits of maths that make us go, or make us get curious or make us want to dig in. And not everybody else has. And there is a sense that if they haven't seen it, that's why they think they don't like it. And it's not because they don't like it, it's because they haven't seen the bit that makes them go, I want to know more.
That's right. I 100% agree with you.
I'd like to talk more about this, but I fear if we keep talking about it, we'll use up all our time. So why
Okay.
don't you show us a curiosity or a magic trick or however you want to
All right.
describe it, and we'll come
All right.
back to some more
I
general
have a
things.
little magic trick for you. Hopefully, the technology work. I'm going to try and share my iPad so it can be a little bit high tech with this. So give me one second.
Go for it. If when it's running, I'm going to turn my video off, and you can have the entire screen.
All right, let's see. And then I'm going to ask you to play along with me.
Really, I get to get involved.
You're going to be my volunteer.
Whoop whoop. I
Given,
can
given
see. I
the
can see.
virtual nature of this. All right, so presumably people can see my screen. Maybe even
I'm
see
certainly
me
seeing a
now.
screen. So for the moment, I'm going to turn my video off. If you want me to appear on with a video, then just tell me if that's useful.
Okay.
If you
All right.
my shocked expression can turn up, but for the moment, I'm going to give you the space. All right.
All right, perfect. So as you can see here, I have a grid, an array of numbers here, numbered 1 through 16 in order left to right, top to bottom. What
Lovely.
I'm going to allow you to do, Ben, is I'm going to allow you to pick 4 numbers from this chart. And right now, before you even pick the numbers, and obviously you and I have not talked about this before, we've never even met before until just now. So I have no idea what numbers you're going to pick. I am going to predict the sum of these 4 numbers. So what I'll do is here, I've got a little piece of paper, got a little marker.
Okay.
I will write down the sum that I know that you're going to make right now.
How could you possibly know what I'm going to do now?
And what I'll do is, I don't want people to think that I have like a whole stack of papers here that I could draw from after I know what the sum is. I'll take the sum, I'll crumple it up, and I don't know, a good place to leave it in view. I think That's in view right there, right?
Yeah, I can see that. I
Cool.
will
So
keep
I
my
can't touch
beady eye
that.
on it.
There's no sleight of hand here. I don't know how to do that kind of magic. All right. So what I'm going to do, so you're going to get to pick 4 numbers.
Okay.
I'd like you to pick a number from the first row, 1 through 4 there. Give me a number.
From the first row,
Yes, sir.
I will pick the number 1.
I knew you would do that. All right.
Stop scaring me, all right?
I had a
It's only
sense
just Halloween.
pick number 1. Okay. Here's the thing, though. Since you've picked one, I think it's only fair that we take care. We're kind of done with the first row. And we'll go ahead and cross out that first column where the 1 is. So we're just going to take those out of the equation. So
anything in line with my number, you've just got rid of.
Correct. Horizontal and vertical.
Yeah.
And now I'd like you to pick a number from the second row, 6, 7, or 8.
I see. So because 5's crossed out, I can't go there. Fair enough. I'm going to pick the only perfect number on that row.
Oh, are you testing me?
No, I'm going to tell you that I want the number 6. The only other perfect number, I guess, no. 6. 6 is the perfect choice.
All right, we'll give you 6. We'll take out the rest of the row. And we'll take out the column that has the 6 in it.
Nice. Okay.
Go ahead and select a number from 11 and 12 in the third row.
I do like the number 11, but it looks too predictable, so I'm going to go with 12.
I'm glad you did that. And I kind of figured you wouldn't go straight down the middle. I knew that in advance. We'll take those 2 out. And, I'll let you choose the last one. So it's totally up to you what you want to pick.
Semi-prime. I like the semi-primes. 15 or
right.
15 will do me, yeah.
I'm going to give you 15.
Thanks.
Once again, I was pretty sure you would pick that. So now let's go ahead and over here on the side, we'll sum up your numbers. Whoops, not 16, 15, right? What is that? 27 and 7, 34?
Yeah, I think it is.
Yeah, you want to check my work, make sure I didn't goof anything there?
I got a 7, and the 12 is 19, and the 15, 34. 34, I agree.
All right, rock and roll. Here is the piece of paper that I had crumpled up and written on.
No way.
Slow reveal here. Let's see what we got. Oh, it's blank, actually. Is that right ways for you?
That is the right way for me. I am impressed. That is the number that I picked.
I believe that says 34.
It does say 34.
It does say 34. So one might wonder, how is it possible that I can know that?
And let me just put my guarantee on this.
Yes.
Although I've seen your work before, we've never had a chance to chat, and we certainly didn't rig this. And I genuinely was trying to pick numbers that you thought I wasn't going to pick, and I was, wow, okay. So is this a thing where I want to know what's going on, and I suspect a lot of people watching, but we've had a lot of chat on some of the other guests already that you may have seen, that there's a tension with magic. Do you reveal secrets? And that the same tension is in mathematics if you're trying to provoke curiosity, because too early a reveal maybe ruins that hook.
The longer I can maintain the suspense, the better. So I like to use this. As a teacher, I like to use this with students, right? I share this with other teachers as well.
Yeah.
So, imagine doing this with a bunch of 8-year-olds or 9-year-olds. They're super excited. How does he know? He's obviously not magical. I may look magical, but I'm not magical.
I was going to say, it's not that obvious. You look pretty magical to me.
So, the next thing they want to do is they want to try it again. Like, hey, can we do this again? All right. So
okay.
A good mathematician would probably say, no, I don't want you to do this again. But let's go ahead and do this one more time, and let's just see what happens.
That's a really interesting comment about magic, where the job is to keep the secrets, would refuse to repeat. Whereas those people who want to uncover the secrets, which is maybe a good metaphor for mathematicians,
I think
will repeat until secrets unravel themselves. So I'm up for repeating it.
All right, so let's repeat. So I'll just erase all this. There we go. We're clear. And go ahead. Same thing. Pick a number from the first row. Don't pick one. I was
going to say, it's not going to be fun if I pick the same. So I'm going to go with 3.
All right, 3. Oh, wrong button. 3. So we'll take out the first row and we'll take out that third column. Go ahead.
I do like the 6, though, so I'm going to stick with 6.
All right, sticking with the perfect 6.
Yeah. I can just see the chat is going through. YouTube's like, what's a semi-prime? What's a perfect number? I just opened a can of worms there. I'm sorry.
That was a lot of extra conversation for us.
Yeah, too right. We'll come back to that later if we need to. I like square numbers, though, and I'm not going to explain that either. 9.
Can I just say I knew you were going to go with the square number?
Wait, does that mean you're going to predict
another square number? What are the odds? All right, there you go.
I don't know the answer to that question. Good. Okay, so 16, and those are my 4.
Yep. So 16 and 9, 25 plus 9 more. Oh no, 34. I guess I can use the same paper.
Hey, it
I
was
think
off
we have
camera.
to
You
do
maybe you
that
just wrote
again,
that again.
right?
Okay,
So
that is
obviously
34.
the jig is up or whatever they say. So we kind of know, we got to have a sense of what's going on now, right?
Right, and mathematicians might call it a conjecture. The conjecture is, wait a minute, is this always 34?
Yeah, is this some invariant thing? It's always 34. I don't know. So we could obviously do a few more. I think at this point, um, you know, how do we make sense of this? How do we make sense of, can this be 34 every time? And if so, why?
How do you feel about me throwing ideas out, or do you want to tell me more
No,
about
no,
what I should look at?
let's dialogue. You throw some ideas at me.
I feel like the structure of the grid forces something, and the way that you cross out the numbers obviously means that I can't. If I pick three, say, I will never be able to pick the number four more than three. That feels important, but I can't put that into words any better than that. So
Yeah, yeah.
because the grid's four wide, there's like the steps four up from that are not going to
There's
be
something,
available.
there's obviously something going on when I disallow all of these numbers, right? What do these numbers have in common? Well, they're all multiples of 4 plus 3, I guess.
Or multiples of four subtract one by the same
Or
grid.
multiples of 4
Yeah.
subtract 1. Absolutely. We reference the right side. We could think of it that way as well, right? So at the end of the day, what's going to happen? You're going to end up, I'll just pick 4 random ones like this, right? You're certainly going to end up with 1 in each row and 1 in each column.
Agreed.
And so why don't we pick you started off and you were like, you're kind of headed down the diagonal, and then you were like, no, never mind, that seems too boring. Let's just give you the diagonal.
Okay, yeah, because I nearly got there
I
for
mean, that's
real.
that's as good as any other choice of 1 in each row, 1 in each column, right? Now, let's say you pick these. We can add these up. These are going to be 34 again. I think some people might notice that there's maybe kind of a easier way to add them up. If you think sort of like Gauss, maybe like pairing up 1 and 16 gives 17, and pairing up 6 and 11 gives 17.
Okay, yeah, and that's
So you
half of
sort of have two
34.
17s going on there.
Yeah.
But let's think about it this way. Let's say I allow you the opportunity to move one of your choices. So
So
let's
if
say in the
I
second row, instead of the 6, you can choose another number in that second row.
so let's
And
go with the 7 then.
okay, great. So we'll give you the 7 instead. So we'll take the 6 out, right? Well, that now invalidates your 11. You're not allowed
Yeah.
to have 11. So we got to cross your
Huh.
11 out. What's the only number you can have in the third row?
Well, I have to sort of replace that column that 6 was in, so I have to go to 10.
You got to go to 10. And what just happened there?
We went up by one in one row and down by one in the other. Okay,
They
nice.
balance each other out, right?
Yeah.
There it is. So we could play around with this more, but I think people could play with this now and figure out, okay, every time I move these things around, there's this balance going on. I'll get a few more over here, but I'll lose a few more over there. And in a way, you can think of the diagonal as kind of the neutral position or something. So
yeah, it's kind of like I'm
that's
forced,
it.
but
Now you know
I do
how
have
to-
free choices, but though the first free choice forces enough that it's
Yeah,
always going to be your prediction. That's lovely.
yeah. And there's so many ways we can go with this now. So we could say, okay, that's fine. We figured this out. I always like to leave people with extra questions. So 34 is the magic number for the 4x4 grid, right?
So I have questions. I mean, you do. Oh, there we go. Yeah, you're reading my mind.
Did I anticipate your next question?
Well, I had two questions. One is that we don't have to do 4x4 grid, but I'm
Yes.
thinking maybe we have to do a square grid. I haven't quite formalized that because of rows and columns kind of.
Yeah, my rule makes rectangles kind of tricky, right? Because
They're kind of
you
like you.
allow for many more degrees of freedom, I guess, if I give you more columns, let's say.
And well, I'm never going to get to the last row. If I go down row by row, they're all
Yeah,
gone by the end. So maybe
yeah.
they still. And,
So
yeah, I'm
I haven't,
freewheeling a bit.
I
Sorry.
haven't fully formulated what this might look like on a rectangle, but I challenge anyone who's watching to try it and see what if they can come up with a rule.
But I was also thinking you don't have to start at 1. Yeah, like if you added 10 to every number, suddenly we've got a bit of flexibility, and
You
maybe
don't
your
have to count
prediction.
by ones either. You could go 2, 4, 6, 8, 10.
That's nice too.
So
Okay.
now we're getting into sequences and series and sums and all that stuff, right? We're into middle school at least. We're maybe into high school a little bit with a third grade math problem or a second grade math problem.
So I guess the
Would you
question
like to
is,
try the 5x5?
yeah, should we try it or?
We can do whatever you want.
You're. I'm just here to facilitate. You're the one with the
All right,
magical method.
let's try the 5 by 5, and
Yeah.
you can imagine that I'm about to make a prediction. I'll make a prediction for this one.
I'm desperately trying to get there ahead of you, but I'm gonna do what Ian was talking about, and actually just allow the surprise to be profound by not getting
All
it.
right, and then I'll do the old crumple effect.
Lovely. That's
Put
such a
that
lovely reveal, by the well.
behind
Forget the
the
maths. The way that you sort of put that out there is it's there hidden in plain sight. I like that performance part of it too.
Appreciate that.
Okay.
All right, go ahead. Pick a number in the first row.
Right, 4.
There you go. Oh man, that is a fun pen right there.
Exciting pen.
Yep,
Okay, that's nice.
Going with the square numbers. Interesting.
8.
8.
That means I've gone square, cube. No,
Oh yeah, you got a cube.
I'm in trouble now. Okay, we'll go prime.
Prime.
Now I'm testing you.
11.
Yeah, there we go.
Testing me on live television or live YouTube. That is not cool.
Now we'll go even.
Even. Oh, that one I can do. So,
and I think I'm forced then to do another even one.
you are forced
Okay.
to there. All right. So we have 4, 8, 11, 20, 22. Let's see. Some quick math. 30, 50, 65.
I think I agree.
All right.
I'm loving the look of anticipation on your face. Look at that, 65.
I mean, come on.
So the obvious big question that everybody who's not sort of done this before is, given an n by n cube, like generalizing, like, so if it was 4 by 4 give you 34, 5 by 5 give you 65, you've got to know like what would a 10 by 10 do, even if that would be a pain to actually do as a
that
trick.
would be the next math question that us math types would ask, right?
I really love the fact that magic captures that sort of curiosity of maths to generalize. Like you want to know, first of all, wait, is that always going to work? And then how do I know it's always going to work? And it forces into algebra and generalization. And already,
how do I know what the magic sum is every time?
Yeah.
Without drawing out the whole, I mean, if you want to do a 10 by 10, I don't want to sit there and draw a 10 by 10 grid. I mean, I can.
Agreed. But it kind of, the maths gives you the power. If you can solve that problem, then you could do 100 by 100 without drawing it out, assuming you've solved it, right? And then
exactly. So
lovely, Raj. Where did you come across this piece of maths or magic?
You know, that's a great question. I'm not sure where I saw this first, but I'm, like I said, on the mission to make math irresistible. So I just, you have your spider senses out looking for, oh, this could be useful in a classroom. It's got some accessible mathematics. How can I make this into a little bit of a trick? Because it's all how you present it, right? I mean, I could have just presented this as, here's a 4 by 4 matrix. By the way, if you pick one from every row and every column, you get you always get the same number, and it's 34.
Right, and then what actually is an amazing fact becomes
all the joy and wonder out of it, and that is exactly what 98% of school math is like.
I agree. Yeah, and even the best intentioned teachers, like, it's another bit of creative step to find the way of provoking the curiosity, isn't it? Which is why I commented on your placement of the paper, because even though that's not the maths, it's the bit that sort of dangles the curiosity in front of us. And I really appreciate it. That's why I love this show. I teach maths and I love doing magic, because they both exhibit that curiosity hook, and they provide the fuel to go and do difficult things like mathematics, like solve what is the magic constant for an n by n grid in Raj's trick here. Actually, I have a question about the trick.
Yes.
Since you pointed out that it's the rows and the columns that matter. Mm-hmm. And basically, I'll fill up one from every row and one from every column because of the way the rules work. But does that mean we could switch rows and columns? Or rather, not switch rows, but I could take one row somewhere and put it in a position of another row and put the other, and also
like take this column right here maybe
and switch it with
column.
Yeah. And then all the things you've just said will still be true if I go through and cross out rows and columns with the numbers I pick.
It seems like they would be, yeah. I think
I would. Now, but it would be fun because you could present what looks like a much more random.
Oh, we could. Oh, see? That's awesome. All right.
I'm loving it already, and I want to go and tinker, which is a good sign. Maths is happening and curiosity is being provoked, at least in me. I have no idea about the rest of the audience, but
that's fun. I didn't think about that. Yeah, I learned something new. Yeah, and what you said, we could start from different numbers. We can try different step sizes. And then there'll probably be some things, there'll be many things that we could do that would break it, right? So it might be interesting to think about how are all the ways that we break it? What if we
Yeah.
did
There's
other
another classic mathematician trait of like testing the extremes until it stops
Yeah,
being working.
yeah, yeah. I mean, I will say here, like you could, I think since I've circled the diagonal, again, if you use the little Gauss trick of working your way in,
Yeah, then there may be
26, 26, and 13, which is half of 26. So it's two and a half 26s. So where does 26 come from? Size of the grid plus one, right?
right. And so the 4x4 had
So
a
we're basically getting to an algebraic expression here for what it is.
yeah, and it comes from our natural tendency to pattern spot. So the 4x4 17 was important. Hey, that's one more than 16, sort of. And oh wait, I love that because that doesn't involve like deep sort of advanced knowledge of mathematics. That's spotting something, but then the challenge is, wait, is the thing I spotted real? And now is a good excuse to go and try a 6x6, right?
It's this is so much fun to do with students. I've had them notice that, oh yeah, they see the diagonal is 34, and then they wonder about the other diagonal, and they're convinced before they add them up that there's no way it can be 34.
That's great.
And then obviously it is.
So when we asked everyone to contribute to this 24-hour magic show, we said, bring a trick, talk us about your background and do the trick. I think Katie also mentioned, because it's Halloween sort of time, that if you wanted to talk about a treat, I not quite know what that was defined as, but is there anything else you want to tell us about? Because before we run out of time, I'd love to actually ask a little bit more about any projects you've got coming up in the future.
Well,
but
yeah, so while I'm here, I would love people to know about the Global Math Project.
Tell us more about that.
You're familiar with that probably. The Global Math Project, globalmathproject.org, is an organization, nonprofit, dedicated to trying to bring joyful math to classrooms across the globe. And it's centered around James Tanton's Exploding Dots, which is an amazing story, visual story of place value, and gets into algebra and arithmetic and beyond. It's just, you have to see it to believe it. It's wonderful stuff. Everything's there on that website. So I'd love for people to go check that out if they're looking for other things. And if they're looking for me, they can find my website, drrodshah.com, where I try to post these little puzzles and problems every week on my YouTube channel. So
excellent.
My thing is just, how do we find ways to get kids to dive into the mathematics that we want them to learn all the time?
And do you think this is changing? I mean, that there is, you and I both know, a perception of mathematics as a stereotypical sort of dull, cliche-ridden, correct, always about truth, not about emotion. But you and I know it's not like that. Do you think that's changing out there? Because you see people trying to change that now.
I do think it's changing. I do think you're starting to see like words like beauty and joy show up in curriculum documents for different countries or states or whatever, educational bodies that control a lot of this stuff top down. And certainly from a teacher level, there's so many teachers who would like to do this, but like, who has time to go find all these surprising things, right?
Yeah.
If you're teaching, especially in a pandemic, you're overwhelmed. You can't find this stuff. So there's people like me and you and others that are trying to, in every way that we can, put stuff out there for people to just take and use.
So do you have a favorite place to recommend other than the Global Math Project and your own website of where people can go to find these good nuggets of mathematical joy and wonder? Do you have a go-to place? So someone mentioned Martin Gardner, who wrote all the columns in Scientific American, who died a few years ago, unfortunately. But like, what was the inspiration for you? And does it still exist? Can you go back there?
I don't know that I have one go-to place. If folks have never kind of followed James Tanton, he's got videos and all kinds of stuff online that you can look at. And most of them are curriculum related, which is really nice. Because a lot of things you find out there, they're really cool, but like they don't necessarily relate to what kids are supposed to learn in school. And so they have a different purpose.
Yeah.
But my focus being with what I do, working with teachers and with kids and stuff, is how do I make it curriculum relevant? So I would go there. Obviously, Numberphile. I feel like I sort of know you by having watched probably every Ben Sparks Numberphile video.
I'm sorry you've had to put up with that.
Oh my God, they're amazing. I mean, we use so we talk about this. We use you talked about the pandemic and GeoGebra, right?
Yeah, that was the one I did like really in a hurry in March.
High school students, and we taught them how to use GeoGebra and model the pandemic. This was back in April, I think.
That's really fun to
Uh,
hear.
yeah, and I mean, it was great because they could have these conversations about what do these things mean and what should our leaders be doing under these when we have so many variables and we don't know what's going on and we, all this stuff. So making it that's how we get kids to get into this stuff.
Yeah, and I mean, making it relevant. It's a funny time, isn't it, with this pandemic, which is obviously a tragic mess, but and yet more than ever before, the mathematicians are obviously the ones with the power, for good or for bad. That's the scary thing. But the ones who are modeling this are the ones that have the information. And I mean, while it's a tragic situation, as someone who's trying to point out that maths is important, useful, beautiful, creative, and necessary, it's more obvious than it's ever been, perhaps, in the last 6 months, isn't it?
Absolutely.
So we've got 2 minutes left, and I'm officially meant to check that the next person is in the call. But are there any other shout outs you need to make, Raj, before? Did you see any of the previous performers? Had you come across any of them before? I know it's a different time.
I've been watching most of the performances. I've been pretty impressed. I thought those visual illusions were amazing.
Yeah, Matt's optical illusions are,
and they're head scratching. You just look at them and you're like, how did that thing disappear? So those kinds of things I think are really cool. Again, things that just make you go, what is going on with this thing?
Well, I'm really surprised at the complete variety, and I'm actually send a message to James from me saying, why are you not involved? James would be a wonderful person to have, and I inexplicably not made it onto the list. So next time we do a 24-hour math magic show, we expect James to, do his international math salute like what happened earlier. Raj, can I say thank you so much? Should we do it? Wait, was it explained earlier?
It was kind of explained. We can do it again. Yeah, so if you want to do the international math salute, you put both your hands out like this.
So, yeah, sorry, yeah.
And then you cross your hands over, and then you twist them until they clasp, and you wiggle your pinkies, and you wiggle your pinkies again. And when you're ready, you just go boom.
And I don't, because
and you're locked. Yeah. So I think the best way to explain it is to do it in reverse. Think about.
So you want to be like that, and then and actually that's good advice out there for the rest of any magic trick you want to see. If you can want to try and work backwards from the outcome that happened and dodge the bit you think is impossible, then that's a good way to unpick it. I won't say too much more about giving the final way. Raj, thank you so much for joining in. I hope you enjoyed the rest of the show, and hopefully we'll cross paths again in the near future.
Thanks, man. I appreciate it. This was awesome.